Hello students, I am Kinjal Parmar. Welcome back to the video lecture series of microprocessor and microcontroller. Today we will discuss AVR Timer 1 programming. So let's start. For Timer 1 programming, AVR Timer 1 is a 16-bit timer and has a lots of capabilities. Since Timer 1 is a 16-bit timer, its 16-bit register is split into a 2-byte. These are referred to as TCNT1L, TCNT1H, that is timer 1 for low byte, timer 1 high byte. Timer 1 also has two control register named TCCRlA, timer counter 1 control register A, TCCR1B, timer counter 1 control register B. The TOVl that is overflow flag bits goes high when overflow occurs. So this timer 1 set its TOV1 flag. There are two registers in a timer 1, OCR1A, OCR1B. There are two separate flags for each of the OCR register which act independently of each other. When TCNT1 equals OCR1A, then OCF1A flag will be set on the next timer clock, and when TCNT1 equals OCR1B, the OCF1B flag will be set on the next clock cycle. So depending on which OCR flags are set, either A or B, according to that flag will be set or reset. This timer 1 have a different beats. So as timer 1 is a 16-bit timer, the OCR register are 16-bit register as well as they are made of a 2 8-bit register. For example, OCR1A is made of OCR1AH high bit and OCRAL, that is OCR1A low byte. The TIFR register also contain TOV1, OCF1A and OCF1B flag. There is also an auxiliary register named ICR1 which is used in operations such as a capturing. ICR1A is a 16-bit register made of ICR1H, ICR1L. This timer 1 have first TCCR1A. So in a TCCR1A there is a COM1A1, COM1A0, COM1B1, COM1B0, FOC1A, FOC1B, WGM11, WGM10. So COM1A and COM1A0 both bits are compare match output for channel A, and next is for channel B. Then FOC1A, FOC1B, this force output compare for channel A and channel B, and this WGM11 and WGM10 is for timer 1 mode. Next is the TCCR1B. So ICNC1, ICES1, then unused bit WGM13, WGM12, CS12, CS11, CS10. This ICNC1 is the input capture noise concealer. This 0, that means input capture is disabled, 1, that means input capture is enabled. Then ICES1, input capture age select. So when 0, capture on a falling edge, 1, capture on a rising edge. So these all are the bits for input capture function of a timer 1. And next is for WGM bits. So here we have a table. So in this timer 1 there are so many modes are used over here. So WGM13, WGM12, WGM11, WGM10, these all are bits are used to select this total 16 mode. When 0000 normal mode, then for 1 there is a PWM, for 8 bit 2, for 9 bit 3, then 10 bit, then for 4 we have a CTC modes and so on. So these all are the timer 1 modes. According to that, bits are selected, but mostly in a timer 1 also normal or CDC mode are used for the basic operations. This next is a TCCR1B clock selectors. So CS12, CS10, CS1, so here we have all the bits. So 000, then no clock source, 001, that means clock but without prescaling, then 010, then clock with prescaling of 8, then with prescaling of 64, 256 and 1024, and then last two bits 110 and 111 is used for external clock. So external clock on a T1 of a falling edge, external clock on a T1 of a rising edge. So this all are the bits of TCCR1B. So here we have a timer 1 programming. Write a C program to toggle port B.4 bit continuously every 2 millisecond. Use timer 1 normal mode and no prescaler to create the delay. So first calculate the values for TCNT1H and for TCNTL. So here we have a clock frequency, so we can calculate this time duration. No prescaler, so here we have a 0.125 microsecond. Now divide this 2 millisecond by 0.125 microsecond. So here we need 16,000 clocks. So it will convert into this hexadecimals, and first either subtract and then convert, or subtract then write the bits. Okay, so here we subtract this bits from FFF. So here we have a value that is 0xC180. We can perform this subtractions here for 4 times FFF because this is of a 16 bit. For a 8 bit we perform subtractions out of FF from 256. Here we have a 16 bit, so 2 raised to 16 minus this clock. Okay, so here we have a value in a hexadecimal that is 0xC180. So 80 is loaded into TCNTL, C1 is loaded into TCNT1H. Okay, so write a program for this to toggle the bit and then generate a delay. So include AVR IOH void T1 delay int DDRB is equals to 0x output port, then while 1 port B is port B this, and 1 / PB4. So it will toggle the bit of 4 and T1 delay. So here we use a function T1 delay, and T1 delay is calculated over here like this: TCNT1H is equals to 0x C1, TCNTL 0x80. So C180 is loaded in a TCNT. Then decide the bits of TCCR1A, TCCR1B. So for TCCR1A all normal mode, so 00, and in a TCCR1B normal mode and no prescaler, so 01. So we have to check now TOV1 flag. So when TIFR and TOV1 flag is equals to 0, wait over here. Whenever TOV1 is equals to 1, then execute the next line. In the next line there is a TCCRB is equals to 0. So it clear the counter and stop the counter, and TIFR clear the TOV1 flag. So this is a timer 1 programming in a C for this kinds of delayed. Thank you.